There are different problems that we do that involve finding the center of mass, and there are problems that use the center of mass to find something else. So this is a center of mass example that is kind of the classic example of a problem where you would use center of mass. We call this kind of a canoe problem or a boat problem. Let's say I have my dock that is here. I'm going to have some water, and I have a boat. Inside the boat, I'm going to put a dog. It's wagging its tail. I need some measurements. So let's give this dog a mass of 5 kilograms, kind of a little guy. And we're going to give the mass of the boat to be 20 kilograms. Pretty light boat. We're going to say this is, let's call that 2 meters. And we will start the boat maybe a little bit farther from the dock. Sorry, doggy. We're going to start the boat a little bit farther from the dock, just to make sure that we've got some room to work with. And we'll call this another 2 meters. So what's going to happen, we're going to stand here at the shore, and we're going to wave and hold up a treat for the dog. The dog is going to come to the opposite side of the boat until it's over on this end. And because of that, the boat is actually going to move farther to the right. So we need a couple of things. We're going to need where the dog is to start with from the end of the boat. We're going to call that a half meter. And let's figure this out. This is a center of mass problem. Now the way that I know for sure that this is a center of mass problem, other than that, I've done these before, is this dog on a boat is a closed system. There's nothing else going on. So when the dog moves, it'll exert a force on the boat will exert a force on the dog, but there's nothing external exerting a force on the whole system. If there's no net force on the whole system, then that means the center of mass is not accelerating, right? We said sum of forces is equal to mass times acceleration. If the net force on the system is 0, then there's no acceleration, so the center of mass stays where it is. So let's find where the center of mass is right now. I'm going to need some kind of a coordinate axis, and I'm actually going to put my coordinate axis, in this case, right here at the edge of the dock, because I know that that dock isn't going anywhere. So there's my X. My center of mass position is going to be X boat, mass boat, plus X dog, mass dog, divided by mass boat plus mass dog. It's a one-dimensional problem, so we aren't going to have to do any of the Y stuff, or maybe I should just say the center of mass of the system vertically had better be wherever they all are. So mass of the boat, I'm going to get 20 kilograms times its position. The center of mass of the boat is a uniform shape, so its center of mass is right here at its own midpoint. So that is 3 meters, right? 2 meters to the edge of the boat, another meter to the center. 3 meters. Plus, mass of the dog is 5 kilograms. Position of the dog, 2, plus another, right? If that's a half there, then this is 1.5 here. So 3.5 meters. And I'm going to divide by mass of the boat plus the mass of the dog. Let's do that math. 20 times 3, that's 60. 5 times 3.5, that's 17.5. 60 and 17.5 makes 77.5 kilogram meters on top, dividing by 25 kilograms, and that's a little bit easier. That's just 3.1 meters. So the center of mass of my whole system right now, getting rid of this stuff, the center of mass of my whole system right now is at 3.1 meters. There's 2, there's 3, so like here. That is 3.1 meters. Now let's look at what happens when the dog moves. So I'm going to slide this up a little bit, and I'm going to let the dog move. I still have my dock. Still have water. And now, my dog is going to have moved to the left side of the boat. The boat's going to have moved to the right side, to the right some. So I'm going to draw this here. I said my coordinate axis was at the dock. So let's see what is what. We have, in the end, a position of the dog. So we are looking for where the boat ended up. We have a position of the dog. We're going to call that X. And then we have the center of the boat right here, which is going to be, well, we know from the end of the boat to here is 1 meter. So from the dock to here is going to be X plus 1 meter. And now we can solve. I'm going to move this up a little bit more. Alright, our X center of mass is going to be the same formula. So I'm going to have 20 kilograms for the boat times X plus 1 meter. And then the dog is going to be 5 kilograms times X. And I'm going to divide that still by the entire mass of 25 kilograms. My center of mass of the system can't go anywhere because all the forces that I've had have been internal. So that center of mass has to come out to be 3.1 meters. And now I've got something I can solve. I have 20 kilograms times X plus 1 plus 5 kilograms times X. And I'm going to multiply this 25 up. So equals 25 times 3.1, which is 77.5 kilogram meters. I'm going to distribute this out. 20 kilograms times X plus 20 kilograms times 1 plus 5 kilograms times X, and I get my 77.5 kilogram meters. I can combine these two terms and get 25 kilograms times X. I'm going to subtract the 20, so it equals 57.5 kilogram meters. And X is 57.5 over 25, which is 2.3. So let's see what I've actually solved for. The dog is now 2.3 meters from shore. It's at the far left side of the boat. So we just found that this is 2.3 meters. It's at the far left side of the shore, or of the boat. The far left end of the boat was 2 meters from the shore. Now it's 2.3 meters from the shore, so the boat moved by 0.3 meters. To the right, or away from the shore, if you like. That's the canoe problem.